Hey fifth graders, this is Mrs. E here, and I am here to help you on your fifth grade homework. This is building on what we've been doing together in class in our special fifth grade lessons. So this is page 3 and 4. I want you to put your name at the top so I know whose hard work it is I'm looking at, and secret shape is going to be a pentagon, because a pentagon has 5 sides. I like to make it like a little rooftop, and then the sides coming down, and then the bottom. So a rooftop with 2 sides in the bottom makes a 5-sided polygon that is called a pentagon. Okay, friends, we have been doing a lot of multiplication in class, and we're going to be extending it into our fifth grade thinking. So here is our multiplication connections. This is page 3 on your blue paper. So to multiply a number by a 5, this friend Marissa, she first multiplied it by 10 and then found half of the product. So we've been using a lot of doubling and halving strategies. So it looks like Marissa's using this also. It says write an expression with parentheses to show how Marissa would solve 24 times 5. So our example shows that she started with 24 and then she first multiplies by 10. So here I see times 10, and that's why it's in parentheses, because that's what she did first. And then she finds half the product. So half means to divide by 2. So what is 24 times 5? Well, 24 times 10 is 240, and half of that divided by 2 would be 120. So I love her strategy of figuring out these bigger numbers. So let's look at this one. To multiply a number by 12, Carter likes to multiply the number by 10 and then multiply it by 2 and add the products. Here's a picture of his thinking. Now friends, I do this in class all the time. I just don't always draw it as an area model. So it looks like he's multiplying 16 times 12. So in class, I might do it like this. You've seen me do this lots of times. I take that 12, I break it apart into a 10 and a 2. Then I can multiply 16 by each of my partial factors here. So 16 times 10 is 160. And here I see that on my area model. So here you see 16 times 10 plus 2. That's our 12. And we can fill this in. 16 times 10 would be 160. So that's the same as I had over here. So fill in that partial product. We talked about this a lot in 4th grade. And now I have 16 times 2. And you're going to fill that in right here, 16 times 2. Now if you don't know what that is, you can always stack them and add them. 16 times 2. So 6 plus 6 is 12. And 1, 1, 1, there it is. 16 times 2, that's 32. You know what 16 times 10 is. You just write the 16 and add a 0. And we have it right here. And then finally, you're going to add them together to get your full product. So our total product would be the total area of the partial products added together. So that's going to go right down here, 12 times 16. It says write an expression with parentheses to show how Carter would solve 12 times 16. So let's do that. Let's do that in our partial products here. So I guess I'm going to go ahead. I hope you already have it filled in, but I'm going to go ahead and fill it in. 10 times 16 is 160. We had that right here. So I know this box is represented by 10 times 16. So let's write that. 10 times 16. And that's this partial product. So let's put parentheses around it. And then this product down here is 16 by 2. 16 times 2. So let's add that down here, 16 times 2. Put parentheses around it. That's this bottom level of our area model. And then to find the total, we just have to add those together. So this is an expression with parentheses right there, right? The parentheses group each of our partial products to show how Carter solved this. Now, it's not an equation because it doesn't have an equal sign. It's just an expression. If I put an equal sign with the answer, now it would be an equation with two equal sides. So what is it? Add them together. 160 plus 32. Boom. There is your total area, your total product for 12 times 16. So go ahead and fill that in on your own. Number 2, Sophia's using a different strategy here. So Sophia says to multiply a number by 99, she likes to multiply by 100. Now, this works because 99 is so close to a very friendly number. So she's going to multiply by 100 and then subtract one group of whatever that factor is that she's multiplying. So here's a picture of her thinking. It looks like her factor is 8. So it's 8 times 99 is what she's trying to figure out. So she says she multiplies by 100 first. So I can see that in the picture. It's an 8 by 100 area model. So let's write that part of our expression with parentheses. She did 8 by 100, 8 times 100. But then she didn't need 100. She only needed times 99. So she wants 1 less 8. So taking away 1 less 8 would be minus 8. So this is an expression with parentheses to show how she solved this. So what is it? Go ahead and figure it out. What is 8 times 100? Well, that's 800. And then you've got to subtract 8. Now, I know 10 minus 8 is 2, so I'm pretty sure I'm going to have a 3-digit number here. And it's going to be less than 800. It's going to be 700 something, right? Because I'm going to go back 8, so it's 700 something. And I know 10 minus 8 is 2, so I think my ones place is going to be a 2. So what is this? 800 minus 8. Fill in your final product right there of 8 times 99. I like Sophia's strategy, being so close to a friendly number. Okay, and we are going to flip it over to the back, my friends. We're halfway done. This is exactly what we were doing in class together during our 5th grade time. We're going to fill in the dimensions of this 3-dimensional box. So it looks like we have 1, 2, 3 layers. There's 3 layers. And I know because of the commutative property of multiplication, it doesn't really matter which number goes where. But I know there's 3 layers, so I've got my 3 there. And then let's see what are the dimensions of these layers. Let's count this. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's a 9 by this dimension. 1, 2, 3. 9 by 3. So it's 3 layers of a 9 by 3 grid. So the dimensions, just like a rectangle has dimensions, a rectangular prism, or a 3-dimensional rectangle, a rectangular prism has 3 dimensions. That's why we call it 3D. 3D stands for 3 dimensions. So we have 3 by 9 by 3. Okay. And fill in, I guess we didn't need to solve it. We could solve it, but we didn't need to solve it. We did talk about in class that you could solve it in any order you want. You can do 9 times 3 and then multiply that by 3. I feel like my brain would like to do a 3 by 3 times 3 first. So 3 times 3 is 9, and then I know 9 times 9. That's a fact I have memorized. So bonus points if you write the volume. Volume equals blank units cubed. These aren't units squared, they're units cubed because we're talking about volume. Okay, number 4, how can you solve these? We are multiplying by 2-digit numbers. So again, use that pull apart trick. 2 times 13 is the same as 2 times 3 is 6, and 2 times 10 is 20. So I get 26. If it helps you, take it apart down below. 13 is the same as 10 plus 3. So you can take it apart one step at a time. So 4 times 10 is 40, plus 4 times 3 is 12. And I can put those back together to get my final product. 40 plus 12, and write your final product there. Okay, keep going. Let's pull these apart. 13 is the same as 10 plus 3. And I love multiplying by 10. It's easy peasy. So 8 times 10, you know that, 80, plus 8 times 3, ooh, 8s, those are nemesis. 8 doubled is 16, plus one more 8, be a 4 and a 4, that's 16 plus 4 makes 20, 24. 8 times 3 is 24. Now put those together to get your final product. 80 plus 20. 80 plus 24. Okay, now this one's nice and easy. Any number times 10 is just that number, and I can add a 0 on the end because 28 times 1 is 28, but it's not ones, it's tens, so I can add my 0. Okay, let's try taking it apart. Oh, now this, wait a second. I can use the trick from the beginning, Marissa's trick. Anything times 5, I can just multiply it by 10 and then cut it in half. So let's try it. 28, instead of times 5, I'm going to double it to get times 10. So 28 times 10 is 280. And then I can cut it in half, divide by 2. If I multiply by 2, I can then divide by 2 and it stays the same. So what is half of 280? Think, what's half of 28? And then just add that 0 onto the end. Or these are both even numbers, so what's half of 2? And then what's half of 8? And we added the 0 back on the end. So that's a 3-digit number. Can't wait to see how you guys do on this. Okay, 28 times 15. For this one, well, we already figured out 28 times 5 right here. So that's part of my 15. Let's go ahead and do that. 28, you should have, half of 28 is 14. So check your work there. I just gave you the answer. So let's look at this one. 28 times 10 is 280. 28 times 5 we just figured out is 140. And now you can add those together. So those are each a partial product. Add them together to get the total product, the total answer. Okay, and finally, we can use lots of different strategies for this one. How 13 times something is 52. So you can start skip counting. You could do a ratio table. How many 13s does it take? Well, I know 1 13 is 13. I know 2 13s is 26. Okay, I have to get all the way to 52. I could try doubling and doubling, see if that works. So you want to get to 52. How many 13s is it going to take? So lots of different strategies we're using there. You guys are doing great. So finding the products means the product is the answer to a multiplication problem. So here I'm noticing, wait a second, hold on. What do you notice about all three of these expressions? 2 times 5 times 8, 2 times 8 times 5, 5 times 8 times 2. I mean, they all have 3 factors, so they must represent 3-dimensional rectangles, rectangular prisms. But I also notice something else. It's the same 3 factors, and we know that we can start with any 2 factors we want because of the commutative property. Also, this shows the associative property. We talked about that a little bit in class. Remember, we used our parenthesis hands to show how numbers are associating. So let's just follow our order of operations and do parentheses first and see how this works out. 2 times 5, that's easy. write your product right here and then multiply by 8 and you've got that answer. I'm gonna freeze. Oh, I can't freeze on this thing. I wish I could freeze. Okay, you pause. I want you to try this and then come back and check your answer. Okay, hit pause. And play. And I bet we have a match. 2 times 5 is 10. 10 times 8 is 80. Now this one is going to be not quite as easy. 2 times 8 is 16. And then times 5. Let's use that double and half trick. So instead of times 5, I can do times 10, which is 160. Let's do times 10 equals 160. 16 times 10, but it's not times 10, it's only times 5. So let's cut it in half. Half of 16 is 8, and it's 80. We have a match. So 2, 5, 8, 2, 5, 8. It's the same factors. Let's check it this way. 5 times 8, I know that's 40. And 40 times 2, 4 times 2 is 8. Add that 0, we get 80 again. So because of the associative property, when you have 3 factors, you can choose any 2 factors to multiply first. Okay, which of the problems in item 5 is the easiest for you to solve? You. I know which one I like best, but which order would you prefer to multiply the 3 factors? They all have their own strategies that helped us solve them, but which one did you like best? So I liked, and write it, blank times blank times blank. Oops, I meant to put a blank there, I accidentally put an 8. I like blank times blank times blank because why? What made it a little bit easier? Okay, we're going to do the same thing again. So same thing again, 3 factors. We're finding the product and then which one is easiest for you to solve. So this time our factors are 6, 7, and 10. 6, 7, and 10. 6, 7, and 10. Now, I know 6 and 7 live in a shoe. We know this trick. 6 and 7 live in a shoe. It must be size 42. And then multiply that by 10 to get your final product. Now this one starts off easy. 6 times 10 is 60. And I know if I'm multiplying a tens by a number, I can just forget about that 0, right? 6 and 7 live in a shoe. It must be size 42. And then add that 0 back on at the end because it wasn't just 6. It wasn't 6 units, it was 6 tens. So let's make it tens. And then finally, this one, we have 7 times 10 is 70, and then do the same thing. 7 times 6, write your product, and then add that 0 back on at the end. Blank, and add that 0. So you can do this, 5th graders. I know you can. Which one did you like best? I know which one I like best. It's similar to the one on number 5. So I liked blank times blank times blank because why? What made it a little more friendly for your brain? Okay guys, that is your 5th grade math homework. Congratulations. Do your pentagon up there at the top. This is September, so write the date right there, and I will see you in class. Goodbye.